So I just started recording. So if there are any questions, put them in the chat. I have the chat up here. So what we're going to cover today is it's kind of, we're making a little bit of a switch. So we've covered, we went through all the kind of the simple formal languages, and then we kind of touched a bit on SQL and kind of the basics of SQL. And now we kind of confront the main or one of the main issues in databases. And that is, how do you actually design a database? So this is actually really, this is going to occupy maybe the next 3 lectures or something, 3.5 lectures. First, we're going to cover the entity relationship model, which is a conceptual model, which that'll be the subject of today, and maybe into the next lecture. But then we're going to cover after that is normalization. What we're going to cover is normalization theory, which is kind of traditionally the hardest part of the database course. The thing is that, I mean, it's pretty clear that the decision of how you actually define the database. So you're not really completely stuck with it, but you're kind of stuck with it once you make the decision. So a lot of times, what you'll have is lots of different stakeholders have to be involved with the decision. You see, I just want to make sure that this recorder is working. Okay. Lots of different stakeholders need to be involved in it. So there's a lot of people who don't have technical backgrounds, but they know kind of what the database has to do, what the requirements of the database are. So if this gets done improperly, so what are the mistakes that can be made? One is that there was no real good communication of what the requirements were, and then when you finally deliver the database, it doesn't really do what was intended. That is that can happen. A lot of times, what happens though is that maybe like the design or the basic, for instance, one problem might be performance, depending on how large the database is. So you have to design the database so that it's going to be performant. That's another issue. But one of the main issues, I think, is basically requirements creep or requirements ambiguity. That tends to be one of the major problems. So there's lots of examples of this, but I know of one example. This happened in like the FBI's files program, which actually had to, like, it was the United States program. It was a big government program where they didn't. There was requirements creep. They kept on adding more and more requirements. The data team never really caught up. They really weren't doing good conceptual modeling, and then the whole project had to be killed by an act of Congress. So there was like hundreds and hundreds of millions of dollars that were burned up. And the same thing happens in industry as well. So it's just, if you can't get everybody kind of on the same page as to what are we trying to really model here, if you don't do that, then major problems can happen because you have to kind of implement something. So if what you're implementing from is a bad design, then of course it's going to be a bad result. All right, and then there are various ways to try to repair that, but it gets pretty desperate when this goes bad. So this is one of the reasons why this ER stuff, if you're really good at this ER stuff, actually, I mean, you have to have a bit of reputation as well. But if you're really good at ER type stuff, you can definitely command like $150 to $200 an hour consulting, because it's a little bit like companies don't want to skimp. It's like people don't skimp on getting brain surgery. I mean, they pay for it. So the same thing with like doing the actual model of a database when they're rolling something out. They are willing to pay for talent to do this because there's a lot of mistakes there's a lot of pitfalls, and it's not the kind of thing you want to do that you want to do on the cheap. So conceptual modeling is kind of a big deal in that regard. Okay, so let's get into kind of what it is. So the purpose of an ER model. First, we're going to go through slides, and then we're going to break off, and I'm just going to kind of show it. I'm going to write it down, which I think might be actually more instructive. But let's just at least cover the slides here. So the ER model allows us to sketch the database schema design. So it gives us a way to kind of specify some of the constraints, but not really being so specific. Designs are pictures called entity relationship diagrams. Now, in the end, when you do this, so I mean, I think that a lot of you guys have had experience with like something like UML, and UML is not really, you can't really translate UML out to it doesn't give you really kind of that much guidance in terms of actually something you can implement, but actually ER diagrams do. So let me actually at this point just go over here. So there's a diagram I want to show here. Okay. This is essentially saying what I was saying before. All right. I want to show something here in the diagram. So let me just stop the share here. And let me see here. You guys can see this. Of course, I have to open the chat again. All right. So this right here is the kind of the model of what's called physical data. This is the model of this is kind of how things really work ultimately. Let's start this over here. Okay, I don't need to put a box in. That's great. Okay, I trust you guys can read that. Or yeah, I have, and you know those tablets. I have to say one thing about the tablets that are really annoying, and I think that actually people might have seen this in good. You can read it. People might have seen this in recitation. One of the problems with those tablets is that they're not fast enough. So every time you write on the tablet, it's kind of like trailing behind you. It's terrible. It's got terrible ergonomics. I think at one point they need better performance on those tablets. I found them completely. It's horribly annoying to write on. Actually, what we need is a document camera, but I've kind of rigged one up here. Anyways, so there we are. Anyways, all right. So this is like the 3-level model of databases, you might say, in general. So the idea here is this conceptual model, at the conceptual model level. This is what we're going to talk about today. So these are ER diagrams. So we're going to work with the ER diagrams today. And then the thing is that I always kind of show it this way. When you finish with the ER diagram, you push a button on it, right? And this means that it automatically, or let's be honest, semi-automatically translates this into the representational model. And for relational databases, that's a set of relations. So R, S, so okay. RS, R1, R2, okay, you can say it that way. So a bunch of relations, a bunch of table definitions plop out of the actual conceptual model, okay? So that's the whole point. We're gonna do conceptual modeling here, and then we're gonna push a button on it, and then out is gonna plop a bunch of table definitions which have primary and foreign key definitions inbuilt, okay? So, and then this right here, these, of course, when, let's say that we go to PostgreSQL or we go to Oracle or we go to, MySQL or something. When we put those in there, then that actually defines something that sits on, that really does sit on disk, which is the physical model. So this is like the data structures and I mean, this is tremendously complicated here. But these are all like your, the actual files that represent the database. So it's going to be different for Oracle or PostgreSQL, et cetera. So they all kind of do that no matter what they want, the way they want to do. So the idea here then, but now if we have our tables here and we pound it out, so let's say Oracle, all right, so we pound it to Oracle, we can also, see, we can push a button on it basically. Now this is actually not so easy to push a button on. Okay. But the idea here is that what we can do is we can pound this out, these table definitions, we can pound them out to Oracle, we can pound them out to PostgreSQL, et cetera, et cetera, et cetera. Okay. So the idea of, so what we have is we have the notion of physical data independence. Okay. And what that means, it means that it doesn't matter, we can switch out the actual physical database, all right? And we also have a notion of representational independence as well. So in principle, these ER diagrams, when we push the button here, it could knock them out to an object-oriented model. Okay, object-oriented model. It could knock them out to a document database model. Document database. It could, in principle, it could knock it out to anything. So the idea is there's an independence here. So in the modeling, we're not necessarily going to relational, although almost always we do. But it's just to keep the idea that the conceptual model is working at much more of a high level. Okay, but you can push a button on it and plop it out into something more concrete, and then you can push a button onto that and plop that out into something absolutely concrete, right? That actually sits in and actually does something, runs, right? Okay, so I hope that's kind of that gives at least some sense of kind of the overall project. So now what I want to do here, I think that the best thing to do is just to kind of show it kind of the classic way first. All right. So we have the notion of what's called an entity. Okay. And this is kind of equivalent to basically a noun. Right? So could people okay, first of all, what example do we want to develop today? Because we're gonna do a little bit of this in kind of in real time here. Could people do you want to we can do an example of banking, we can do an example of the university, we can do an example of web pages, we can do an example of boats, and we could do an example. I mean, what do we want to model today? We're gonna build a database that does something today. Does anybody have an idea? Just put it in the chat if anybody has an idea. Web pages sounds good. Okay. People. All right. Any other ideas? It might be nice to have something really concrete, really kind of physical, like patients and doctors, what are the things that like countries and politics, countries and I don't know. Anybody else have any other ideas? Like cars and manufacturing, or I mean, we want something, maybe something really kind of tangible would be good. Really physical, so we can kind of see it. We can have it let's say that, how does this sound for people? We're going to be like Rixhem, or we're going to be like Bustaden. Does that make sense? We're going to have I'm sorry, not students. We're going to have per people, and we're going to have apartments, and we're going to have them renting through time, and we're going to have where the apartment, this kind of stuff. Does that make sense? Do we want to do do we want to basically become a little Bustaden here, or we could be more kind of entrepreneurial, and we could be one of these, we could be a realtor or something, where we sell these things or something. Does that sound all right? People want to do that? Apartments? Okay, good. We'll do apartments. Okay, so let's just do a kind of an idea map here, or okay. So what are some of the nouns in the apartment domain? What are some of the entities, the things? I'm waiting here. I'll give them the names that you guys give them here. Okay, vacant or occupied. Yeah, that's more of an attribute on something. So that's we'll get to that. But vacant or occupied, that's kind of like an adjective. You can think of almost like attributes as being adjectives, but more or less. But what are the things that are a focus here when we talk about? Okay, I got two of them here. I have apartments. I'll keep it on the singular here, right? And then sure, and we have an area. All right. So what the area could be like Oostposten, it could be Oldham, kind of stuff. What else do we have? Okay, a landlord and renter. Okay, that's right. So we have a renter. So renter. It sounds like rentier. The rentier class. Okay. Renter. We'll call it a renter. And then we have a landlord. We have an apartment, we have an area, we have a renter, and we have a landlord. Any other nouns in the domain? Anything else? I mean, it's up to this. We're going to do this together here. I do thank the people who actually participate in the chat and kind of put this stuff in. Yeah. All right. Yeah, well, let's say, okay. So these are the nouns. Now, what are the verbs? So now that's an entity, and we're covering entity relationship. So we'll say relationship, which is basically equal to a verb. Yeah, the amount of rooms. All right, that's going to be like a property here. So I'll say a number of rooms. And notice here how okay, notice here what I say, number of rooms here. And how I put like a number sign and then a space and then of rooms. So, you know, when we think about like putting stuff in the database, we know that well, that actually can't, that's not like a legal identifier. But at conceptual level, right here, that you'll have people scratch this kind of stuff into these things. So you have to let them kind of put the kind of their descriptions, which are full descriptions, not things that are kind of legal identifiers. But sometimes you want to. Okay. But anyways, I put a number of rooms in. Okay. What else? Anything else? But that's actually, this right here is actually a property, or what's called an attribute of an apartment. But what are the verbs? I'll write the verbs in red. Living and paying. That's right. All right, living and paying. So who lives, rents? Okay, so that's good. So this is good. So we have some candidates here. Rentor. No, rentor, that's a noun. Because rentor is that's like we already have renter covered. Renter pays landlord. Okay, so let's do that. Okay. That actually is an interesting one. Okay. Here's the, first of all, just to show you a little bit of the notation here. The a little old-fashioned notation. The entities are represented by the entities are traditionally represented by boxes. Rents out. Yeah, rents out. That's a good one. Rents out. So landlord rents out an apartment. Is it okay though, just because the person said rents out, is it okay if I just say a landlord owns an apartment? Is that okay with everybody? So an apartment is, because what's nice about that is it's like a pure like little relationship where a landlord, I follow the Shakespearean credo of like neither a borrower nor a lender be. That's the anyways. So a landlord owns an apartment. Is that okay? Yeah. Okay. So that's a verb. So owns. Yeah. So to own something. So I'll say owns, and then we'll basically connect this landlord. So this is an entity relationship. So a landlord owns an apartment, and then you might, you know, it's kind of good practice in a way, but what you can also use, you can put the inverse direction, is owned by. Okay, so apartment is owned by a landlord owns an apartment, right? So you get the right, but that's just something to kind of, we'll at this point just leave that off. That's a kind of a more lexical issue. But we say, okay, landlord owns an apartment, right? That seems reasonable. All right. Now, what about this business of lives in? So who lives in an apartment? Is it the landlord? I guess they could. No, the lives in is also a relationship, a verb that goes between the renter and the apartment. Am I right? And let's call that lives in. Or let's be a little bit more official here. Can we say occupies? Is that okay? occupies. So a renter occupies an apartment. Okay. Let's keep it really simple right now. Let's keep it really simple. And let's just for the time being, because I want to, I mean, the area here, how does that work? Area, that might be an area blank an apartment, or an apartment blank an area. Can someone give me a verb for that? Resides. Apartment resides. Maybe a better one. So the thing about, because resides is a little bit, I don't know, what was my criticism of resides? Let's see. Okay, the resides that's our best candidate right now, but we're looking for maybe something a little bit more direct. So an area, an apartment, an area has an apartment, but that's not really, we don't really want to do it that direction, it seems. We want to say an apartment. Okay, could someone please fill in the blank? An apartment, verb, area. I mean, verb or phrase. Apartment, phrase, area. Is an area of location. Covers. An apartment covers an area. Almost. I think covers is close, but it's not. Like, it's kind of like if you have an apartment, like Old Hem. Okay, my apartment, blankety blank, Old Hem. Or my apartment, blankety blank, Uts Postan. Apartment within? Can I say is within or within area? Apartment with, is that reasonable? Can I say my apartment is within Old Hem? Okay, yeah, good. So good. I'm good. All right. A rent. Now we're almost done here. A renter. Landlord. This would be. Oh, okay. What is a renter and a landlord? A renter, what landlord? Pays. Okay, we'll go with pays. Okay, let's stick with this. Okay, so is everybody clear? So this is an ER. This is our. We don't have attributes yet. But we're gonna put them in. Okay. Rents from. Pays or rents from. We've got a flaw in our model here that we're going to uncover, but I want us to go through this because we're going to see kind of some of the complexities that are involved here. Okay, an apartment, a landlord owns an apartment. Okay, so all right, so let's get some attributes here. What are some of the attributes of an apartment? And now it's going to get a little bit trickier. So let's just say, what is an attribute of an area? With some attributes, these areas. Here, I'll just do it. I'll just and we'll see. Yeah, it's got a name, like Old Hem or something. All right, so I'll just put that. So traditionally, and this is kind of just historical reasons. Let me just show it to you so you see it. So traditionally, what you do is you put these things off here as these little bubbles, these little oval bubbles are the attributes. But that's just horrible because, and we'll see that modern tools don't do that. They will list them underneath. But that's just historical. You'll see this bubble notation. It's in the slides as well. But it's a terrible notation because it doesn't stack well. All right, so we have name. What else do we have for an area? Mean income? Sure. All right. Population, sure. I think like population density or something. Let's just say it could be city. Now you could also represent city as an entity, but we're just going to plug it in there as that. That's okay. Could have public facilities. That's right. Yeah, I mean, you could do lots of like modeling of this, right? So you could sit there and say, does an area have certain like is it like walking distance, or does it have a does it have like a shopping center or something? So like Tomtibu does not. It has like a little kiosk, but it doesn't have a shopping center. Or I guess it kind of does now. Anyways, right. Okay. So renter. What are the attributes of a renter? They have like a name, and let's just keep it at that. An age, a gender, and most importantly, what they have is they have a PNUM, persona number, which we're going to underline because that's the key. Income, sure. Right. Landlord is also going to have a PNUM. What else might and a name? Okay, let's just stick with that. All right. Right. Okay. An apartment has number of rooms, and let's just do the following because we want to make our life easier. We could say the name of the area is the primary key, but let's just do the following. Let's just give it an ID, okay, and make that the key. Because as far as I know, that these names across all of Sweden there can be some clash. I mean, I think I was searching that once. I mean, there's like Norrmalm. Isn't there some other place like Stockholm has a Norrmalm? Isn't there another place that has a Norrmalm? Or no, Vasastan. I think Haga. Yeah, Haga is that. So we want to. So, but notice here, if we didn't do that and we just left the name as the primary key, then later on we could wind up, thinking, oh, that sucks. We need to revise that. So the thing is that we're doing this because we want to like start I don't know. We want to start a landlord business. I'm not sure. Do we want to do that? We want to start some kind of brokerage for postal number. Yeah. That's right. So there's addresses of what is that postal? I guess for these guys. Anyways, it can get really complicated if we start thinking about like postal numbers. I mean, does every area have a unique postal number, or how do we like? Now here's an issue also. The renter's address. What is it? Should you derive it from the apartment that they're renting? I'm not really sure about that. You want to maybe see where they're bookkeeping addresses or whatever. But anyways, there's a lot of complexities that can come in here. Number of rooms. Let's give this an ID as well. We could say something like this. We say like a floor plan. We can have like a description. We can have a lot of different things. Size. Yeah, that's right. Quadrat. Size. Yeah, the postal number should definitely be okay. Zip. I'll call it zip. That should definitely be under apartment. I guess the more interesting question is that what is the renter's address? That's more than, so do we want to put an address? Yeah, and landlord would be probably an address. All right. Although the landlord owns an apartment that they don't rent out, right? So anyways, okay, but I think that we're getting a little bit, maybe a little bit of sense of the feel of kind of how these things would go. Okay. Now let's talk about something that is it's kind of a key issue, and that has to do with what's called the cardinality of relationships. Cardinality of relationships. Yeah, I don't know if you guys can see this. The cardinality of relationships. So this has to do with, okay, first of all, each of these guys, each of these squares, these are entities, right? Entity, entity, entity. So we have 4 entities. Or what we would want to say, really, if we want to be really specific, we really want to be accurate, we would call these entity sets. Because a renter is an entity, it's a noun. But this actually represents entity sets. It's a set of renters, a set of landlords, a set of areas, and a set of apartments. Now, the relationships, or the relationship sets, as you would be like all the ways that landlords map to renters. So you might have some landlord that has, has 100 renters, right? And you might have some renter that has 100 landlords. Maybe. You have to think about this. Now, let's now the thing is that let's say, because the thing is that a lot of times what I mean, if we talk about the real world, like the real world, let's see, can you get a natural, most relationships are many to many. Okay, most of the relationships are many to many. Now, let me just wave my hand here right now, if I may, just wave my hand here and say this is a snapshot in time database. Okay. Now we don't want to have it. We would like to have it so that things kind of, we can show like if I rent from an apartment, I'd like to have I like to put like a date here and a date here on the payment. So, and even a date on the own. So apartments change hands between owners. So you understand that if we put in the dimension of time here, the whole thing becomes much more complicated, right? I mean, strictly speaking, okay, I don't know. This can get really complicated, but I want to keep it a little bit simpler. I want to just keep us, kind of. So let's just consider this to be a snapshot database. Right? Snapshot meaning that it's one snapshot in time. All right. Which means, okay, so now the question is this, is that does a renter occupies an apartment? You might say something like this, could say, okay, first of all, let's just say this. Can a landlord own many apartments? Can an apartment, we're talking about in a snapshot in time, can an apartment be owned by many landlords? Now you understand, if we're having these kind of discussions, and I'm sure that you guys are probably already thinking, oh my God, this is really, really tedious. Okay, so all right, someone said yes. So yeah, we'll talk about this, but I hope that people understand the question that's being asked. Okay, we all agree that a landlord can own multiple apartments. That's fine. Now, can an apartment be owned by multiple landlords? In a snapshot in time, we have a choice here. Now we can say yes, we are going to allow for joint ownership of apartments, but that is going to complicate our model considerably. Okay, or we might just say no. There's always going to be a primary owner of an apartment. It's kind of like this, like trafikverket. You guys know that you cannot have joint ownership of a vehicle. I don't know if you guys know that. So if you have a car and you and your sambo say, well, we want to joint own the car, you can't do it. Trafikverket say, no. You got to pound it out to one owner. All right. Now let's be like Trafikverket, and let's just say here that we want to pound it out so an apartment has to have one landlord and only one landlord. Is that okay with people? We're going to do this. Now you notice here, these are really tedious discussions. So like maybe some higher up people would be like, or different higher. I mean, let's say that we have like 10 people sitting around in a meeting. They're all stakeholders, right? And we're all having these discussions over the model of the database. Can you understand that these kind of questions that I'm asking at this point, we're going to have some of the people who are going to start zoning out and thinking about what they're going to have for dinner that night. They're going to zone out. You're going to have somebody who should actually be paying attention now, zoning out, because it's getting very tedious to kind of specify these things. And I think historically, at this point, a lot of like the, CEO types who were kind of too cool for school, that they would kind of say, okay, you guys figure this out. This is giving me a headache. I want to go off, to the golf course. Right? But that's a big mistake because you got to get this right. Because if you don't get this right, you're gonna live with the consequences, right? But in the old-fashioned notation, which we're gonna actually do crow's feet notation, but let's first do the old-fashioned notation, which is what the slide's done. In the old-fashioned notation, it's kind of the way you represent that. I'll do old-fashioned in blue. The way you represent that, an apartment, let's say we're saying an apartment can only be owned by a single landlord. The old-fashioned, Chen's original notation, is you put an arrow here, which means that if I have an apartment, that's going to determine a landlord, right? An apartment is going to map to a landlord. Boom, right? That's the old-fashioned notation. Let's show a little bit more of a modern notation, which is the one I prefer that you guys use, which is it's very widely used now. It's called crow's feet. And here's how crow's feet works. Crow's feet has some limitations, some problems. One of the problems that crow's feet has is that it doesn't have it gets rid of the relationship. So these diamonds here. So entity, that's like a box, and then this right here is represented as a diamond, the relationship. So, but basically the crow's feet notation will do it the following way. We'll draw a line between, this is landlord, and this is apartment. And it will say, an apartment, okay, so now we got to ask another question. Now, because before, like, we'll get into this in the old-fashioned notation also, but we have another question that I have to ask you guys. And of course, now everybody's glazing over. They're just thinking, "Oh my God, these ridiculous questions that he's posing." I mean, can't you just like get this thing done? So there's a lot of impatience when it comes to this thing. I mean, people hate going through this technicality. People, this is you get a lot of people who are going to zone on this stuff. Does an apartment have to be owned by a landlord? Are we going to allow for there to be orphan apartments that are not owned by anybody? Well, landlord, a company, whatever. Okay. Actually, I'm saying we're going to allow for orphan apartments that are not owned. Well, sure. We're going to allow for that. So here's crow's feet notation. It will say, between zero, let's see. 1 second. I'll make sure I get this right here for the I got it wrong, of course. That's right. That's annoying. Sorry, I need to get more paper. All right, so here's how it goes. Okay, now I gotta do this so that I don't screw it up here. Okay. That's kind of a little bit of a problem. Anyways, okay. I'm going to have to check on this because I remember. What is the max? I'm going to just Sorry, I'm gonna follow my intuition here. Because it's sorry, I know you guys are probably thinking, what the fuck? Right. I probably have this wrong, but I'm gonna follow my intuition, if that's okay with people. 0, 1. I think actually because it's just the way it looks, they invert these, but let's just stick with Michael's growth feet notation here because I think it's actually more consistent. Okay. So this is the minimum number. So if we have over here, we have an apartment. Then an apartment, and landlord, can have at minimum 0 landlords, right? Because I'm saying now we're going to allow for apartments to kind of float free without owners, without landlords. And at most 1, right? Okay. Now over here, a landlord. Now, can we have, let me just see right. When can orphan apartments be a thing in real life? Oh, I think that happens. Sorry, I shouldn't laugh. But if you visit Kronofungen, you can sometimes you can catch an apartment that doesn't have an owner. You know, when the owner or the landlord is yeah. I mean, you could say Kronofungen is a landlord, but they're not really a landlord. So, I mean, can you guys accept that? That might be a reason. You get some cheap apartments from Kronofungen. The problem is there's competition, so other people are looking at those apartments too. So, I mean, Sweden is good in that way. So it's not. I mean, well, anyways. All right. So I mean, I don't want to get into the whole. I mean, you could also have something maybe like a new production, or you could have something that is. I don't know. It's but in this, I mean, but that's a good question. So this is a very good question. So I mean, a lot of it has to do with why are we doing this? You know, somebody might say, well, we don't even need to represent this because we're, you know, we want to make, we're a broker, blah, 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 whatever. But anyways, now let's just say a landlord. Let's see. Someone with no food, yeah. Yeah, exactly. If it goes, yeah, okay. I don't want to. I don't want to talk about that. That's kind of that's not very cheery. Sorry. Our landlords live forever here, so. Yeah. There's lots of so I think the thing is that what's interesting here is that this is exactly how conceptual modeling should work, is that we should start probing into kind of like what is the reality we're trying to model, because we're not building the database for the database's sake. We're building it to model some chunk of reality, right? So all these questions are the kind of things that we would sit around and we would kind of hash out among the stakeholders if we were going to implement this brokerage company. All right, but this is exactly why the ER diagrams are so powerful, because you force yourself into kind of making these decisions at this level, rather than have somebody just pound out all these tables and everybody scratches their head about how the table. Exactly. Yeah. So it's yes, exactly. You could always. That's exactly right. So these things are like. It's like, oh, how can you say it? I mean. It's just, I mean, this is kind of more of a philosophical riddle about how can you get a complete representation of the world, and the answer is no, not really, but you can kind of come close enough for the purposes you need. So it's mostly becomes a pragmatic issue, but it's a deep question. These are deep issues, I suppose, at one level. Well, they are deep issues, but you try bringing that up around them. You try telling these business people, everybody's seeing all these people wearing a suit around the table. These are deep philosophical issues, and no, there's no time for that. Okay, so but let's just finish this up before break. Can we have a landlord in this system here that doesn't own anything? Maybe they're just like a newbie, a beginner. I say yes, right? Is that okay? We'll say that a landlord can actually be an orphan landlord. They own nothing yet, or currently.
But we're going to present that also as the first button. The first thing we put is the 0, and then we have the crow's feet, many. So a landlord can be associated or can own. We're going to just basically call this owns. A landlord can own 0 apartments, or they can own many apartments, and then implicitly in there they can own 1 apartment. But that's that gets covered up. Does that make sense? So this right here is the 0 or more. Yeah, 0. Well, yeah, 0 or more. You could say 0 or more. Yeah, there's a lot of different notations that represent this. So and even I look at here. I mean, because here's the thing. I like to say, I think actually they invert these and they have the crow's feet notation actually will just invert these because it looks prettier to put make this thing a that. But I like the fact that I just say between this and that, between 0 and that when I'm reading in both directions. So I've even myself made a small modification to the crow's feet, right? And that's this just shows that these are nothing really is kind of there's lots of different alternative notations to do this, but the most important ones are Chen's, the original one, which is in the slides, and then crow's feet. The disadvantage of crow's feet, though, is that what you're doing is you're basically the relationships are being like the owns here. These relationships here are just being reduced to a single name of the line. So if we have something like we say, so you could do this in start N, right? Start N. So the starting of the ownership and the ending of the ownership. So if I make it so it's temporal, then it becomes problematic because you don't know where do you put these attributes. There's no place for them to go. So there's a lot of stories about how you deal with that, mostly through a process what's called nominalization, but I won't get into that right now at this point. So in other words, what you can do is you can turn the owned, which is a verb, you can nominalize that and turn that into a noun, right? So you can say ownership record. So an apartment is part of an ownership record, and a landlord is part of an ownership record. So you can nounify this thing, and then you can actually put it into crow's feet, right? If you need to have attributes on the ownership. I hope that makes sense to people, but don't worry if it didn't. But anyways, I think that this is kind of, I think, a good place to pause. This is this is a little bit different than normal. I mean, this is not highly technical what we're doing here, but I hope that people see that it is quite relevant in terms of like the world and all. I mean, you're doing real business and work in the world. That you're getting even this simple little example right here. We're still struggling with this thing. At the end of the lecture today, we're going to have it so that we're going to make some decisions here, and then we're going to show how we can take this and we can pound it out to tables. All right. So we're gonna, but there's actually a flaw in here. I want people to think about this over break. There's a flaw. There's a flaw in here, and it has to do with if we have. Well, we'll come into the flaw, but there's kind of like renter pays a landlord for an apartment. It seems like if let's say that I was renting 2 apartments, okay, we haven't said there's anything wrong with that, and I have 2 different there's 2 different landlords. I'm a renter and I have 2 different apartments that are owned each by a separate landlord. And then I have a record of me paying one landlord and me paying another landlord. But the question is as it stands right here, which apartment am I paying for when I pay a landlord? So we can maybe reconstruct it, but there's a little bit of a problem there in terms of the representation. But anyways, I think I want to fix that in our when we finally pound this thing out to tables. Because I really do want to have a tight record of me renting a particular apartment and paying for that particular apartment to a landlord. So I don't like this. This is my criticism right now of our current model is I think this right now, this is a binary relationship. I think it needs to be trinary. And let's be honest here, if we enter in like another entity here, and I'll call this entity right here, father time, all right, time, okay, which then it might be a quaternary relationship because I mean this right here is basically father time showing up, but you can model father time as an entity, so it gets very, very kind of abstract here. But I'll go back off from that. But anyways, I hope this is interesting to people. At least. I think it's kind of. I think I think conceptual modeling actually is quite interesting. If you think about it, it's a tricky. I mean, it's not in any way complete. I mean, it's kind of an art form as well. Okay, let's take a break. Let's get back at 20 minutes after 9. I'll pause the recording here and just put any questions you have in the chat. Recording. Okay, recording then. I've gone to taking the liberty here of taking this original thing here, and then I'm just gonna represent it this way. I'm using Chen's notation, so I'm using the old-fashioned notation. And there's a key thing about the old-fashioned notation. Let's say that we want to say that, okay, let's get this one here. Let's get this right here. Now, can't see. Can you, oh, now maybe. Is it better? I hope too bright. Oh, yeah. God damn it. Sorry, pardon my French there. My whole curtain fell down, and I need to replace it anyways. Good grief. I'm too lazy to go to the store and deal with it. So, anyways. I like one comment in the chats about like there's not only okay, makes me think that not only there's not only the regulations that make things authorities kind of square. Their databases also make them even more square, and that's absolutely true. I had an experience just yesterday where I'm doing this Ika Klassikern where you ski, and then there's different things. So, anyways, I log how much I ski, and then Ika gives me like freebies. But the thing is, I can't use the freebies on the online shopping. And so I called them, I asked them why, and they essentially didn't really have an answer. It's certainly not a regulation, but I think it's a limitation in their database, period. So yeah, I'm not sure if there's a problem with their conceptual model, but they can't represent it. They can't somehow get the data over there, or they're not able to kind of represent, I don't know. But anyways, the point is this, is that many of like the stickiness and weirdness in the world has to do with just the fact that the databases weren't flexible enough. They didn't make them flexible enough. And then maybe not too flexible, because if things get too flexible, then you introduce errors a different way. So it's really kind of, I hope that people understand really why this is so relevant to kind of modern functioning. So doing the proper conceptual modeling and kind of getting these things kind of worked out beforehand is really like critical. All right, so I think there's another good question. I think it'll get resolved as we do this. But anyways, let me do Chen's notation. And Chen's notation is the following. And that is, I mean, I'll just do it by example. Okay, first of all, does an area have many apartments? Yes. Does an apartment have many areas? And we're going to say in this case, no. But we're also going to say that an apartment has to be within an area. You cannot have an apartment without it being within an area, right? So what we do with that in Chen's notation is we make it a kind of a rounded pointy, right? That's like an arrow, but it's rounded. I could have drawn it better. Yeah, kind of like a rounded arrow. This is Chen's notation. So what it's basically saying is it's saying that if you take an apartment, you can map it, and you must map it to an area, right? So the crows, by the way, the crow's feet notation, I just wanted to show you guys that because that is actually what gets used in industry. And there's a big, and I want you guys to be aware of the crow's feet notation, but for now, I think maybe what I should have done is delayed that for next lecture. But anyways, the crow's feet notation, we can forget that for the time being. Let's just go do old-fashioned Chen's, because with that we retain the triangles on the relationships. All right, so an apartment can be owned. Okay, an apartment, again, I say an apartment, but we allow for orphans here. So I say a pointy. So notice the difference between that pointy and that pointy. This is a rounded pointy, which means everything is a total. Every apartment must participate in this relationship. This one here, just the sharp pointy, means that you could have apartments missing from the relationship. All right, so now we have this trinary relationship, because I said I wanted that. So in other words, what I want is and this actually here, this gets a little bit tricky here, but let's just go with it here. So if I have a renter and a landlord together, does that determine an apartment? All right. I'm allowing for renters to rent more than one apartment. Okay. So there's Bob Smith, who's a landlord, and there's me as a renter, and Bob Smith owns 2 apartments, and I'm renting both those apartments. So if I take the renter, me, and the landlord, Smith, can I determine an apartment through rents? The answer is no, because there's 2 of them, right? However, if I take the renter, me, and the apartment, those 2 together, can I determine who the landlord is? And the answer is yes. So I'm going to put an arrow there. All right, I'm going to make it an arrow like that because not every renter and apartment pair has to map to a landlord. If I take the landlord and the apartment, okay, so you can, okay, if I take the landlord and the apartment, would that determine the renter? Yes. If I take the renter and the apartment, does that determine the landlord? And we already said that one, yes. If I take the landlord and the renter, does that determine the apartment? No, that doesn't. Anyways, I think we have all these clear. So anyways, so these arrows, it's a little bit strange here, but these, you can put arrows on these also with the trinary, but it gets more complicated on a trinary, so you see kind of how this is working here. Okay, so we have all the attributes. We have we have the ID and the size, and I'm going to put in the rents here. I'm also going to let Father Time come in here, and I'm going to put a start and an end. Okay, and the end, by the way, we'll see in an actual database when the end, like the valid end time, you could just leave that as a. Let's say that I'm starting to rent something, and we'll see this when we get to the table. I'm starting to rent something, but I haven't, I'm still renting it currently. We can leave this as a null. So that yet another example of so there's no end date. So it's a null end date. Okay, so I have a funny story about those end dates. But I'll refrain from the stories. Okay, anyways, we've got this thing right here. We have attributes there, attributes there, attributes, and attributes, right? Is everybody clear on this? Are we clear on what this conceptual model? Kind of what it. I mean, these are a little bit funny. These arrows on the trinary relation, they're a little bit funny. But let's just back off on that for a second. Let's just see. Do we all agree how this is? Does this make sense? I want to at least get one yes. Or if there's any, okay, good. Okay. Now, that's a button, and we're going to push a button on this thing. And when we push the button on this thing, we want this whole thing to plop out into tables. Okay, so we're going to plop this thing out into tables. Let's go and do that. All right, the very first thing you do in the plop algorithm is all the entities. So step one, all entities or entity sets get provisional tables. And when I say provisionals, we're not going to define the tables yet, but we're going to start to define the tables. So the entities. How many entities do we have here? 1, 2, 3, 4. So we're going to get 4 tables here. So let me palm off these tables here. So let me just start off up here and then go across. So we're going to have apartment with ID and size. All right? And then maybe some more stuff here. We don't know yet. We're going to have a landlord And the landlord is going to have an ID and a name. We're going to have an area. And the area is going to have an ID, primary key, and name. And we're going to have a renter, which is going to have an ID and name. Okay, so all the entities get provisional tables, right? That's step one. Step two, handle one, too many, and one to one relationships. Relationships. When I talk about conceptual modeling, I mean, these are relations. These are relationships. So you want to have this kind of like, when I say relationship, I'm saying that's a conceptual model notion. When I say relation, that's a representational model thing. We can't see right at the bottom of the paper. Okay. Step one, we pounded out all the provisional tables. Step two, we're going to handle the one-to-many and one-to-one relationships. Now, this relationship right here is a many to one. All right, and one to many, many to one, the same thing. Okay, in this direction, it's many to one, so we're going to handle it. Within right here is also one of these here because it is within is many apartments to one area to many apartments. Right. So these are both of these two are going to be handled now, and I'm going to show you how you handle these. So the way you handle these is you handle them via foreign keys. So these, we don't have any one-to-one, but it's we're going to do this via foreign keys. And how are we going to do that? Well, the question is this: is that well, I'll show you first for the apartment, and then we'll figure it out for the area. So the question is this: is that do we add a foreign key to get this many to one, one to many, whatever it might be, this relationship? To get this, do we add a foreign key to the apartment or to the landlord? It's going to be on one side or another. Anybody have an idea? Where should we add the foreign key? Should I add a foreign key to landlord in the apartment? Yes, you must choose one and only one. Or must I put it on the landlord? Okay, let's have how many people, I'm just going to say, how many people think that we should put the foreign key on apartment pointing to landlord? And how many people think we should put it on landlord pointing to apartment? I'm going to wait for a little. I mean, it's like, you know, the wisdom of the crowds. So whatever you guys tell me, I'll do it. Okay, so so far I have a voice. Okay, so far I think it looks like apartment's up by 2, or no, up by 1. Got 2 votes for apartment, 1 vote for landlord, which might maybe the person. Okay, you're allowed to retract your earlier determination. Okay, that's fair enough. Apartment. Anybody more? I mean, we really haven't covered foreign keys, but I think that once we do it here, I think that, so, I mean, the question is, should I add an attribute here for the ID of a landlord? Or should I add the attribute here for the ID of an apartment? it looks like the apartments are having it. So the idea then is that I have an attribute called landlord, which is a foreign key into landlords. And that is the correct answer. Because if I did it the other way, that just says that there's like only a single, there can only be a single one of these. So it means that you would have a landlord, like for instance, ID 45, name is Bob, and this is the particular apartment. But then the thing is, Bob owns more than one apartment. Yeah, I mean, it's a little tricky. It's a little tricky, but I hope that, I mean, that you can see why. Why it's you got to pick one or the other. An apartment has a landlord, and a landlord has an apartment. Yeah, exactly. The foreign key is like saying an apartment has a landlord, and then this one here is that saying that a landlord has an apartment. But the thing is that a landlord has more than one apartment potentially. So that you're basically saying an apartment must have a landlord. Must. Okay. An apartment determines a landlord, or a landlord determines an apartment. The landlord does not determine an apartment because the landlord can have more than one apartment. But an apartment can have 0 or 1 landlords. 0 or 1. How do I represent that? In SQL, it's easy. You just basically make it so that nulls allowed. Right? If it's a total one, so if you have to have a landlord, then you basically say then you declare it as a not null. So in other words, it cannot be null value. But in this case, we're gonna when we declare our SQL, we're gonna have it so that the nulls are gonna be allowed. Make sense? Okay. Now, let's go and let's do apartment and area. If that's okay. So now, does an area determine an apartment, or does an apartment determine an area? So should the foreign key go on area, or should the foreign key go on apartment? So let's have another vote here. Where should I put the foreign key? Okay, one on apartment, 2 on apartment. I want the votes to tally a bit more, and then I'll do whatever you guys tell me. Apartment. Apartment. Yeah. Apartment. Good. Yeah. So it looks like it's going to be apartment. So basically, what we're going to have then is we're going to have area. Now, since you have to be a member of an area, because we're using tense notation here, then this one has to be not null. Okay, that's a condition. It has to be specified, and that is a foreign key into that. Okay, so we've exhausted now we've exhausted step 2. Step 2 has been dealt with, and then step 3, I would basically say reify many relationships. I'm using the kind of the big lower term reify. It means to thingify, or yeah. I mean, I'm not really using it. The reification is something that I want. It's kind of a deeper concept. Reification is yeah. But I just want to introduce the term here. I'm not really sure if it fits exactly here, but it kind of does. But anyways, what we're going to do is we're going to make this concrete. We're gonna okay. Maybe I shouldn't say reify. No, handle handle many relationships. Let's do it that way. All right. So the full relationship we have here is rent. So basically, what this means, rents, rather. What this means is the following: is that what we're going to do is we're going to add. Let's do step 3 here. Is we're going to add a table. So the foreign keys, all you need to do is add an attribute. But for the many to one to many, and one to ones, is you all you need to do is add an attribute to one side or another. With the ones that are many to many, or complicated, or n-array, or these kind of like you might have these you have to kind of turn their own tables. So we're going to do that. So the way you do that is you say, okay, we're going to have a table called rents. Right now, for every entity that is in the rents, for every entity that participates in this relationship, we need to have a foreign key from rents to that. So that means we're going to have apartment, and we're going to have landlord, and we're going to have renter. And these are all going to be foreign keys. So landlord, foreign key, and renter, foreign key. Oops. Okay. And then we're also going to have the start. We're going to also have the start. Okay. Now, if I have a renter and an apartment, that determines the landlord. So renter and apartment determines the landlord. But now we have the start end thing, which kind of complicates things. Anyway. Apartment, rents, start, and end. All these four attributes together could constitute a primary key of this relation. Right now, are you going to do this? No. This actually would be like a big mistake to start trying to kind of trick with this stuff. This is not how you want to do it in the real world. You do not want to have these giant keys like that in the real world at all. So, but that's more of a practical matter. But in terms of kind of like at least like the underlying kind of logic of this whole thing, I was able to kind of get these arrows a little bit built in here. Can I get them all built in? Probably not. Apartment and landlord determines a renter. Apartment and landlord can determine the renter. So there's an alternative, another candidate, which would be this. That plus those would determine the renter. Apartment and landlord, yeah, could be another. So this right here is kind of way beyond the scope. So the thing is, you don't do this for lots of reasons. But it's good for us to start thinking of these kind of things here, because this is going to be these kind of determinations of what can be the key, what can't be the key. This is going to be critical and central to normalization theory when we do it. Reify is not synonymous with materialize. I'm afraid. Reify, I mean, reify. Forget I even said reify, but I want you guys to have reification is kind of a deeper kind of computer science or kind of philosophical or mathematical notation or a notion. It's a bit tricky to kind of to really, yeah. Leave that. Just leave that. Put that word in your mind and put a question mark around it. We even have in kind of like more moral philosophical things. There's an issue of reification. Reification has to do with, well, psychologists talk about reification. Okay. All right. So it's a really loaded term, but it's kind of a nice, it's a nice kind of deep concept. But anyways, let's just in this case, let's just say handle. Handle is keep it general. Handle many-to-many relationships. And the way we do that is we turn them into a table, and then we make foreign keys going out. So okay, so the question is this clear? So now this right here, this thing right here, this we could, okay, I'm not really sure if I understand what's in the chat, but anyways, oh, maybe that, all right. So this table here, these are the tables though. Right? These are the tables that plopped out of this conceptual model. All right. And we can go now to SQL and we can define these tables and start populating the database now. Okay. So we've really kind of, and then we can put that in PostgreSQL and that will determine it physically. So we can actually have a database now that does all this. So I hope that was kind of, kind of at least, I mean, I try to keep it really simple. But are there any questions about this, about what we just did? I mean, there are tools that automate this, but it was also a little bit, it probably best to do it by hand. But at least there's kind of a principle. There's an algorithm that you could input over the conceptual model in principle that would plop out the table definitions. Okay. Are there any questions? Because now what I want to do is I want to maybe go on to some other like concepts in this. Let me just think here. What would be the next thing to yeah, I misspoke earlier. I'm sorry, I did misspoke. This is not really the way you want to say. I said before, I said the cardinality. I should have said multiplicity. So go back into the lecture here, and I should say multiplicity of relationships. Instead of the cardinality. It becomes cardinality constraints. I mean, cardinality has to just think multiplicity of relationships. Use that instead. I apologize for that. All right, what do I want to do now? I want to make some comments on. First of all, I want to make one kind of practical comment here. Rents here. In the real world, what you'll do is you'll give this its own kind of like ID, and you won't do any of this right here. And this right here is called a surrogate ID. So a lot of times your relationships, you won't have like these complicated multi-attribute primary keys. You'll just kind of put in a new attribute, and that's called a surrogate key. So it basically becomes, so you can have a key for this relationship. That's just something that you do. It's just a matter of practice. It's not, it's not guided by theory so much, but it's just a matter of practice. Okay, I think right now what I want to do is I want to deal with something that's called weak entity sets. These don't really come up so often, but they do come up here and there. So let me I just want to show it's a little bit of a quirk in the system of how you represent things. Excuse me. So we would have something like this. We could have something like, we have, this might be good. We have person. Let's start over. ID, which is the primary key. And then we have pet. Dog. Okay, so it's a dog, pet dog. And the dog has a name. Popular names might be Spot, Fido. Even into i Sverige var det vanligaste hundnamn. Anyways, you have the idea of like there's a pet dog, and then there. Does someone give me the name of the common name of the dog? Fido. Oh, okay. So we have like Fido would be an example of the dog. Now, the thing is that there's a lot of Fidos out there. So the thing is, and then we have an idea of, and Fido was not such a great dog. And we have the verb bites. Right. And this relationship, by the way, of the pet dog biting a person, this, I'm afraid, is a many-to-many relationship. Bites is many-to-many, because you can have many, a person can be bitten by many dogs, and I'm afraid that a dog can bite many people, right? Okay, but this right here, this pet dog, is what's called a weak entity. Oops. And the way this weak entity gets represented in Chen's notation is the double triangle. Right. So now we can have like a person, Bob owns a dog named Fido, and we can have the person Sally owns a dog named Fido, but Bob's dog bit Sally. Right? So we want to be able to represent that. Okay. So how do we do this now? Okay. So what this actually leads to, I hope that people understand this is this notion of a weak entity. So the reason why it's called weak is because the existence of this entity is dependent upon a person being there, right? You cannot talk of a pet dog unless that pet dog has a person as an owner, right? So, but now we have this relationship of that pet dog biting somebody. So, but anyways, how are we going to push a button on this thing? All right, how are we going to push a button on this thing? So we're going to, the first thing was, of course, what we're going to do is we're going to like, step one now is going to, is all entity sets get provisional tables. Now in step one here now, we're going to basically add in a step 1.2 or 1.5. And this is going to be handle weak entities. So I'll just go over here. So that's an entity, this is an entity. So we get person, and that has an ID and a name. And we have pet dog, which gets a name. All right. Now the name is not a key. Okay. And it's the way the way the weak entities work is what they do is they go to the they take as a foreign key the key of their owner. All right. So what that means, it means this. And that, so this right here is actually what's called a weak key. So a lot of times you'll see this happen is that they'll put like dotted underlines. So the name is kind of identifying, but it's not the full identification. So name and person is a foreign key up to here. These together determine the key, right? Name and person these together determine the key. So name, and then I'm sorry. This is the person ID. So this is the notion here when I say person. I mean, this is usually how I do it. I'll just have the name of the entity, but what this actually has to be is it has to be something that is an ID, a person ID here, when we actually look at the actual table. Okay, so that's basically that. This is essentially how we handle the weak entities. We allow for the owner's IDs to propagate down into them. Okay, and this and the thing is that all right, this might be, you know, the thing is, I think of these things kind of on the spur of the moment, so I don't want to offend anybody here. But the question is that sorry, I really don't want to offend anybody. I mean nothing politically at all by the following statement. but it could be construed that way. But I don't want to mean anything politically. I mean, this is a politically neutral course. But you could say, and this would get me in serious trouble, so I better be careful here. Let's see, I'll just say the name of the country. And I better be careful about this. Okay, it's too bright. One second. Damn it. What am I gonna do about this? How can I? Oh, I've got an idea. Did that help a little bit? A little bit, maybe? Sadly not. It's too bright. Damn it. That probably helped. Okay, keep the paper more on. Yeah, I saw that because I think it forces an adjustment. Anyways, so okay, so if you really want to get nasty about this example here, you could say that a person, and a human being of flesh and blood, is a weak entity of a country. I'm not saying our countries own us, but in terms of like the IDs only make sense in the context of a country, right? And if I tell you that 5574, Bob Smith, you say, well, yeah, in what country? So we do need the country. If we want to make an international registry of people and their pets, and those pets being bad and biting people, then we actually have to have a chain here of weak entities. So not only was the dog a weak entity, which is insulting to the dog, but the person who owns the dog is a weak entity because they can only be identified by their country. All right. So anyways, I hope that people don't take that the wrong way. Look, people are, I just hope that doesn't kind of register any kind of boundary. So we're talking about in the context of identifying people in the database. Anyways, if that's the case, then this actually has to propagate through in the weak entity relationship. So basically, that means that if I was going to do this now, I need to do the following. I need to basically say, that's right. Yeah, exactly. It's more bureaucratic. It's not humanistic. I mean nothing on the humanistic side of this. I mean, even with the dog, I mean, a dog is a dog. I mean, that dog is unique. You know, we're just trying to model a reality here. I mean, the dog, you know, anyway. Yeah, exactly. Yeah, I mean, so you know, I mean, there's political dimensions to conceptual modeling, or there's dimensions you got to be careful about this kind of stuff. So, anyways, let's kind of do the mapping out to the weak entity. So I say country, name of the country, person. All right, now they're going to inherit their you know, they're identifying countries to identify them. So I say country, and then ID, and that together is their key, and then they have their name. Name could be the key of the country. And then we have the pet dog, and that's going to inherit all the way up. It's going to inherit country, country, person, or owner, country, person, name. And that becomes the full key. Oh, sorry, not with that. The country and the person ID become the key of the pet of the dog. Okay. Now bites. Bytes is going to, now when we do this one here, what we have to basically do is we turn bytes into a table, because now we're going to step 3, because this is a many-to-many relationship. So we have bytes, and then we have to take the full key of the pet dog, which is going to be country, person, name, and I'll say dog country, give it dog person, and dog name. I don't mean a dog person. Person, yeah, you know what I mean. I hope you know what I mean. These are the names. So dog country is the name of the attribute, dog person, and dog name. And then I'll just call this, this is called a role. Victim. And this is perp. This would be perp country. Anyways, say victim. So I'll say victim country and victim ID basically, or something to that. Okay, so you see here now this right here, because this will give us the full record of the bitings. An international, we've made an international registry of dog bitings. So, anyways, but this is just showing you kind of how weak entities that there's this in some ways. I mean, you know, it's basically things become weak entities if we need something that is going to be the jurisdiction where IDs are going to be handled out for them. It's kind of that's kind of how that works. So weak entities, they come up. It's not a lot of times. It's not anything that you need to really kind of focus on so much, but it'll come up sometimes. These kind of notions of weak entities. Okay, so that was a lecture today that gave us an introduction to basic conceptual modeling. Next time, we're going to fill this in quite a bit more. We're going to deal with some stuff with ISA hierarchies. So we have the notion of like different types of things. So we have notions of like, let's say if we say pets here, we might have like pet dogs, pet kangaroos, etc. But anyways, there might be a class hierarchy, kind of similar, but not quite equivalent to object orientation under some of these things. So we're going to deal with classes, and then maybe some other kind of issues. And then what we're going to do is then we're going to kind of then go over into normalization theory, which will give us a much more kind of rigorous basis of how we actually judge the qualities or the qualities of these kind of tables as they get defined. So yeah, so this is, so we're in the mode now of like how you do design for databases. So with that, let's see, are there any more questions people have? Just put them in the chat. I have to answer them. Otherwise, I'll stop recording, and then I will upload this to YouTube and give the link in the course. Next, actually, but see, next we don't have a lecture on Tuesday. We have a Monday. On Monday, it's recitation. So it's recitation number 2, which is the advanced, extended relational algebra and more advanced tuple calculus. All right. Okay, I don't see any questions, so I'll just leave it at that. So, okay, have a good day, everyone.